Hey everybody, this is Will from DSI. We're going to get started here in a couple minutes. I'm going to wait for some more people to join in. So we'll get started here shortly. Cool. Well, yeah, I'm going to get started here. So let me switch over. Cool. So, hey, my name is William Farah. I'm currently a fourth year statistics major at the University of Florida. I've been in DSI for a couple years now, and this is my third year kind of using R, and my second year teaching the R workshops here at DSI. So this is R1, so we're going to cover, we're already assuming you know a bit of the basic syntax and kind of how to use R on a general level. Um, but if you have any other questions, if you have any questions along the way, feel free to drop them in the chat. Um, so yeah, so I've been using R for a little while now. Particularly useful in statistics classes and stuff like that. Especially at UF. A lot of professors use it. So it's a good language to learn, pretty robust and easy to use in terms of readability and stuff like that. So yeah, so let's get started with the workshop here. So I've got R open here. I'm using RStudio as my IDE, and so I've got R1 here. I've created a new script here, and I've just called it R1. So I'm gonna actually take off my headphones because I'm not listening to anything. So yeah, so let's get started with the workshop here. So mainly what we're going to be covering today is if statements and conditionals, in addition to looping variables, and then we're going to load some data into R and then clean it using Plier, which is a part of the tidyverse package. So yeah, so we're going to go through here. So the first thing that we're going to do is create a vector. So let's do that here. So I'm going to go into the line here, and let's create a vector, call it Z. And so I'm using Z, and then I'm using the assignment operator is the left arrow, and then the dash sign. You can also use equals as well, but personally I like to use the arrows as such. And then we're going to give it a value of -3 to 2, so we're creating a vector with length Z. It's going to take all integers from -3 to 2, including those two. So to run a line of code in R, after the line you hit Control Enter if you're on PC, and Command Enter if you're on Macintosh. So let's do that, and then we can see in our environment here, ignore all this other stuff I have, it's like a bunch of stuff from a different project. But as you can see here, we've got a vector Z of length 6, so it's containing 6 integers, and then we can see -3 to 2. Cool. So let me see here. Cool. Yeah, next thing that we're going to do is I'm basically going to show you some useful functions, and then we're going to use them. We're going to kind of apply those functions. So a nice thing, if we're trying to find certain values, we can call the function which. So which, and then open bracket or open parentheses, and then we can do Z greater than 0. So we're basically asking R which values of Z are greater than 0. And so all of our output and stuff is going to be down here in the console. And make sure you're writing in a notebook and not in the console, because anything in the console is not going to be saved. So this is kind of where we can keep things and save them. So it's going to be which Z is greater than 0. And if we run this, we can see that the values that are greater than 0 are 5 and 6. Now this isn't the number 5 and 6, but it's the indice of the vector, right? So the 5th and 6th element of Z are positive. So that's what it's saying for which. We're asking not what specific values, but at which, what vector indice is a positive. So if we want to get those specific values that are positive, we can do Z and then bracket. So in this case, a bracket is we're referring to a condition within the vector itself. So that'll be made clear. So we'll do which Z is greater than 0. So we're basically calling the similar thing before, right? So which thing is positive? Excuse me for a moment. Okay, sorry if my dog barks. She's a little bit crazy, but we're gonna roll with it here. Hopefully she doesn't get too excited. Anyway, so right, it returns the position 5 and 6, right? So when we put in the Z vector, or the Z vector, which values of Z are greater than 0, right? We're going to get those actual values. Because remember, if we're using the brackets inside of a vector, we're referring to the indices. So if we do Z1, right, that's the first element of the Z vector. So this gives us 5 and 6, so element 5 and 6 of Z are 1 and 2. So that's a nice little function to have. So that's really useful if you have like really large data sets, right, and you're trying to find specific values. So you can find the indices, you can find the elements that match your condition or whatever. But to find those actual values, you want to put it inside the vector, if that makes sense. So yeah, if you have any questions, feel free to drop them in the chat. I'm going to be checking it periodically. So yeah, next thing up. So yeah, so let's see. Another useful function is any. So if we type in any, and then let's do z less than 1. So the any function, are there any values of z that are less than 1? And this is going to return us a true or false, right? So if we evaluate that, so any z less than 1, we can see that this gives us a value of true. Yep. So the next thing that we're going to do is look at all. So it's kind of similar. So let's do all, and then z that are greater than or equal to -3. So my font I use kind of combines this together, but what I'm doing is typing in greater than and equal to together, and they're combining for this case, but it will look like two separate characters for you. So let's evaluate that, right? And so that's true. So all of the values in this vector are greater than -3, right? Because we're doing vector v is -3 to 2, right? And then we'll see, we can also use all again. So we can do all where z is equal to 1. So for any sort of like conditional stuff, you want to use the double equal signs, right? Because the single equal signs can be confused as an operator. So when you're dealing with true or false, like conditional statements, or finding a specific value of a vector or any sort of database or data frame or anything like that, you want to use a double equal sign. So we're saying, are all values of z 1? So if we evaluate that, it's obviously false because, yeah, we look at the vector, right? So let me check the chat here. Cool, we still got some people in here. Let me adjust my camera. Make sure it's right. Okay, cool. Yeah, I'm in kind of a janky setup, so hopefully you can see everything. All right, so the next thing that we're going to cover is if-else statements. So these are kind of pivotal conditional things in all sorts of programming languages and stuff like that, right? So this is how you'd set one up in R. So let's set x to be equal to 1, right? So just give it a singular value. It's a vector length 1 of just 1, right? So we're going to do if x is greater than 0, right? So that's going to be our conditional statement. And now to kind of format that, we use the curly braces. So we'll do this. So curly braces, and let's bring this down here so we have more space to work with. So if x is greater than 0, we're going to print this statement. So using just regular print function. And we're going to have it say sick, all right? So I'm going to evaluate that by selecting a line and hitting Control Enter. And x is greater than 0, so it gives us sick. It's super sick. So yeah, we can also compare two variables together. It doesn't have to be just two constants or a vector and a number. So let's set ut equal to 20 and uf equal to 26, right? So we'll just hit Control Enter, and now we've assigned those variables. Or see, I'm slacking here. I'm actually using equals. We'll change this to the arrow. Whoops. Cool. I just think it looks better, but it's all personal preference. So we're assigning ut and uf 20 and 26 respectively. So let's compare the values. So if ut is greater than uf, right? Open curly bracket. We'll print the string Gators win. Right, so anytime you have a string, right, you don't want to just type the string in. You got to use single parentheses, quotes, things. So if this is true, print Gators win, so that's cool. And the Gators did win, so that's also pretty cool. Actually, I misread that, sorry. So if ut is greater than uf, then they didn't win, right? Because it didn't print, because that's false. Because uf is greater than ut, right? So it didn't print anything, which is what we'd expect, right? So it's it didn't print anything. My bad, I misread it. So let's use the same numbers from before, and let's add another condition in. So let's say if, right, from before, if ut is greater than uf, open curly bracket, give it some space, and then we'll do print. Actually, this not should be Gator. Shouldn't be Gators win. It should be UT wins from before, but yeah, that doesn't make sense. Anywho, so we've got print, and then let's say we lost, right? UF lost, and then else. So if and then else, right? So if UT is not greater than UF, we want to print UF1, right? So let's run this, right? So just to recap here. So if UT is greater than UF, then we lost. Else, so if it's not, then UF1. So let's evaluate that based on score. Oh, my bad. I switched up the things here. So this should be actually, my bad, guys. So this should be if UT is less than UF, right? So that, there we go. No, it should be UF. My bad. I'm slacking here. Here we go. So yeah. So if UF is less than UT, then we lost. If UF is not less than UT, then UF won, right? So it's basically just, you know, if-else statements. If you're familiar with any kind of programming language, this would be pretty straightforward to you. So we can do else if to kind of like further iterate and add another step to this. So let's set grade. Let's call variable grade. Let's give it a value of 75. So if grade is greater than or equal to 95, right? Let's print, wow, good job. And then, cool, so that closes that. And then let's do else if. So if grade is greater than or equal to 85, and let's add the curly bracket there so we enclose the statement. Print, let's print pretty okay, right? Else, so if I'll explain once I type it here. So let's print L. We'll just print L, right? So we're giving a value grade, right? So if your grade is greater than or equal to 95, you did a good job. So if it's not, so else if grade is greater than or equal to 85, then you did pretty okay. And so if it doesn't meet either of those conditions, then it's just a L, right? So let's run this. Excuse me, I didn't even. There we go. Oh my lord. I'm goofing. Should be that way. Okay. Right, we got a L because we got a 75. So, cool. Let me check the chat real quick. Cool, we still got some people in here. Alright, let's move on. So loops, right? So loops are pivotal for programming. So let's just show you how to do some loops. So if you've got like an iterative procedure and you don't want to copy and paste it each time, or if it's like over a certain amount of like variables or whatever, right? You want to use a loop. So that's how you do loops in R. So let's make a for loop. So for I in 1 to 10, right? So we're saying for I in the vector 1 through 10, so 1, 2, 3, 4, 5, etc., right? Do this. So we're going to open the curly brackets and then print I, right? So if we do this, we execute this for loop. We look in the console here, 1, 2, 3, 4, 5, blah, 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 blah. So, right, it just printed out all the values. So I is our indice that we're iterating over. So, you know, for I in 1 to 10, so it's going to go 1 through 10. We're going to print that value, right? So let's take this a step further. Let's first create a matrix. So we're going to call this big matrix. And so we're going to use the matrix function, right? And then we're going to generate a bunch of data using the normal function. So our norm, let's do 1,000, 1,015. So we're generating 1,000 numbers, the average being 100 and the standard deviation being 15, right? So that's our data that we're pulling from, right? Because in the matrix function, if we look at the matrix function, by the way, if you're wondering like the arguments of certain functions, sometimes, you know, R shows it up on the notebook here, but if you ever have any questions about a function, you can just type in a question mark, and then it tells you all of the arguments and stuff, which is really useful. So we've got our data, which is this R normal thing that we generated, so 1,000 numbers, and so let's define the dimensions of the matrix. So we're going to do 250 rows and 4 columns, right? So let's iterate that. Let's run that, and then if we look at our matrix, you can see it's got a whole bunch of numbers, 4 columns, 250 rows. So let's create an empty vector. We're going to call this mean matrix row, and then we're going to assign this. So this is the concatenate function. I think that's how you say it. It's like a weird word. So we're basically giving it like an empty value. So if we look here, it's empty. So that'll come into play in a second. So what we're going to do is we're going to calculate the average for each row. So for I in 1, 2, let's do the n row, which is the number of rows in our big dot matrix, right? So what's it going to do for all of these rows? Let's define what it's going to do. So we're going to give the value of mean matrix row I, right? So let's say that on the ith row, so we're going to go through all of them. And so it's important that you have some sort of variable. You can set this to I, X, Y, whatever you want. But it's important you include in here so that way it has something to iterate through, basically. So let's say the mean of, let's give this value the mean of big dot matrix and the ith row, and then we're going to hit the comma. So what the comma says is if we leave this blank, right? So the way you would call a matrix is it's row and then column. So we're saying the ith row, and then by leaving this blank, we're saying all of the columns, right? So what we're doing is we're going through from I equals the number of rows. So we have 250 rows. So it's going to go through each row, and then it's going to generate the average value for each of the rows, right? Excuse me. So let's run that. So cool, so now we have that, and we can view that by just calling it mean matrix.row. We can just do that, and look, boom, we have all these row averages, which is cool that we can do. So yeah, so let's do a similar thing, but for columns. So for I in 1 to n call of our big matrix, right? Let's give it something to do. So let's call it mean. Sorry, we have to define our thing. So let's copy this. Let's bring it down here, and let's call this the mean matrix dot column. So once again, we're just giving it a empty vector because it's going to add all the values in during the for loop, right? So mean dot matrix dot col the ith column, right? So mean of big dot matrix open bracket comma I, right? So now we're saying all the rows but on the ith column, right? So see how these are slightly different. So we're saying the ith row but all of the columns, and this one is all of the rows and just the ith columns, right? So let's run that. Whoops, forgot to define that. Okay, so now if we run that, and then let's look at our results, we should have just 4 values. Alright, so if we enter that, yep, we got a vector of length 4. Cool. What does matrix. Yeah, so basically what we're doing is I'm just setting a variable and I'm concatenating it. So this is how you would like populate a vector. So I'm basically concatenating it but with the empty value. So if we look at our, so I have to define some sort of vector to store all of the numbers into the for loop, right? So it's got to go somewhere. So I'm just defining an empty vector, and that's what the open and close parentheses means. So yeah, so just an empty vector, and then for every time it goes through the ith value for the for loop, right, it just populates it and it stores the values to that. So yeah, let me know if that answers your question, Miranda. Cool. All right, so let's go on from that. Let's see what's up next. I'm going to take a sip of water here real quick. Cool. All right. Awesome. Cool. Glad to help. All right, so let's take this up a notch. So let's kind of spice things up a bit, right? So let's create a vector called ID. So we're gonna populate this with the numbers 1 to 100, right? So we'll hit Control Enter. Let me know if I'm going too fast or too slow too, since you're active in the chat. Let me know. So I'm gonna create a vector called ID and populate it 1 to 100. And so let's create another vector. We'll call it grade. And let's create a random distribution of numbers. So let's do 100 numbers, the average or the mean being 80, and then our standard deviation being 5. Okay. So we're creating 100 numbers, an average of 80 and 5 with a normal distribution. Okay. So let's run that. Cool. So we can verify that it's a normal distribution, right? By we could take a histogram, and let's make a histogram of grade. And so if we look at our plots here, we can see that it's got the histogram shape, right? So that's what the normal distribution looks like. Let's also create a comment. Let's make a vector called comment, and let's give it a vector of length 100 for values 1 to 100, right? Cool. All right, so let's set up our for loop here to kind of iterate through it. So for I in 1 to 100. All right, so what are we gonna do? So let's do kind of a if else statement. So let's kind of merge these two ideas together, right? So if the ith grade is greater than or equal to 85, right? Let's open up a bracket. So if it matches this condition, we'll comment the ith comment for that value will be, whoops. Let's call this excellent, right? So if the grade, so we're going to iterate through basically all of the grades, right? And so we're going to give specific comments for each of the grades. So we're going through all of these 100 grades. So the first thing is if the grade is greater than or equal to 85, then the comment for that grade will be excellent. So let's set up some other conditions. So we'll do, if we want to have multiple conditions, it's nice to have else if, right? So else if grade, the ith grade, let's do greater than or equal to 78. So if that's true, so if the grade is greater than or equal to 78, so if it's kind of between those values, right, we're gonna set the comment, the ith comment for that one to be pretty good. So pretty good. And then we'll do a last one. We'll do else. And then the ith comment will be LOL, good luck. Okay. So yeah, our for loop has closed. We've got all that sorted. Cool. So yeah, so basically what we've done is, so we've created two vectors, both of length 100, right? So we've got 100 randomly distributed grades, 100 IDs, so each student has an ID 1 to 100, and then there's 100 comments, right? So we're iterating through each of those things, and so we're going to evaluate it. So the first thing goes through, if it's greater than or equal to 85, it assigns the comment excellent. So if it fails that, then it goes to the next one, and it says if the grade is greater than 78, it gives it pretty good. So if it's, by using the else if, we're basically creating like kind of bounds, right? So if it's greater than 85, it's excellent. But if it doesn't pass that, right? So if that's false, so if it's less than that, then it goes to if it's 78, if it's greater than 78, then you get pretty good. And so if it fails that as well, then it's just LOL, good luck, like you didn't get a good job. So we're kind of iterating through, so you can kind of set up bounds in this way for the multiple if else statements. So let's run this. Cool. So let's make a little report, so we can do a kind of report. So I'm going to create a variable and call it report, and I'm going to assign it, I'm going to give it a data frame type, so data.frame, right? And then let's populate it with the ID, the grade, and the comment, right? So we're just kind of tying all this together and making it into one concise table. So let's do summary of report. Or rather, we can just actually, we don't need to do that. We can just, if you go into your environment here, it gives you all of the stuff you've kind of used in the session. You can clear this too if you have a bunch of unnecessary stuff. But let's look at report. What's nice about RStudio as opposed to other stuff rather, is that it has a nice like built-in, you can just click on your environment and you kind of view it. It's a lot easier to look at than looking at it in the console. So we can see here, right, we've got 100 students, 100 grades, and then their kind of comments for each of those, right? So let me know if that makes sense. If that's good. Get some water, I'm talking too much. Cool. Let's move on to the next thing. So yeah, so there's an alternative way we can do this as well. We don't need to print each line, right? So let's just create a vector, call it Grammys, and then let's populate it with some strings. So let's do Chance, Adele. It's a bit of an older example, I guess. I mean, it's still probably relevant. Flume, Drake, and then let's do Beyonce. They have the Chainsmokers in here, but I don't really care for the Chainsmokers after they played that that COVID festival in the Hamptons. So I'm not gonna give them the time of day. So let's do character number, and let's give it an empty vector as before, right? So anytime you're kind of making any sort of for loop, right, you want to have something to store all of the values, because every time it iterates, right, you want to capture the result of each of those iterations and stuff. So that's why we're gonna create this blank thing, right? So let's run that, right? And so let's create a for loop. So we're gonna do for name and Grammys. It's gonna do this. So we're gonna do Alright, so this will be made apparent in a second, I guess, when we run this. Alright, so we got Grammys here, which is a string vector. We've got character number, which is a empty vector. And so instead of printing the results, so basically what we did is we printed the okay, basically what we're doing here, right? And so we're saying for all the names in the Grammys, we're creating the variable name. We're creating not the variable name, but the variable is called name in Grammys, right? So it's going to create this value called name and then store it with all the number of characters in each of those names. So it's going to, you know, go through that. So that's another way you can do that. You can kind of set it to a variable rather than printing it out. Because too, when you print something out, it doesn't necessarily store it to a actual variable if you want to use it for later. So it's always nice to kind of store stuff if you're planning on using it later in that sense. But printing is nice for kind of getting the idea of stuff. So the next thing that we're going to cover is apply functions. So the apply family is a group of functions in the base R package. So it's pretty versatile in what you can do. It's kind of like a for loop, but it's a lot easier to see, I would say. It's like the syntax is a lot easier to work with, and I think it's computationally faster than a for loop. So yeah, so it's especially useful if you're working with data frames or stuff like that. And it's kind of a good way to iterate through data frames. So there's a couple of different applies. There's apply, lapply, sapply, vapply, blah, blah, like a bunch of different ones. Those are all different applies. So like vector apply, string apply, all that kind of stuff. Excuse me. So basically the purpose of showing you this is that when you're dealing with matrix and stuff like that, right, it's a lot easier to use the apply functions than writing out a for loop, because apply functions like just make it a lot easier, and it'll be made apparent why those are more beneficial. So let's just start with a basic apply function, right? So we've already created a random matrix from before, our big matrix. So we're gonna do a similar thing. We're gonna calculate the row mean, but instead of making that multiple thing for loop and worrying about all that kind of stuff, you know, before setting the empty stuff and whatnot, right? You just get the row mean, right? So let's do apply, and then we'll do big matrix, big dot matrix, and then 1, and then mean. So what we're doing here is let's first look at the arguments for the apply function, right? So we've got our x here, right? So this is our data. It's our matrix. Oh, let me see if you guys can see that. Okay. You may not be able to see it. I'm gonna try to scroll around, but you can look this up on your own screen if you can't read on here. So it's really useful especially if you're trying to kind of build your understanding of R, is kind of understanding the arguments and the functions. So you kind of know how to troubleshoot it and maybe apply it to other stuff that you may want to do. So the first argument is our x. So it's our matrix, so it's our big matrix. And then the margin. And so we can see here, so 1 indicates rows and 2 indicates columns. This is specific for the apply function. For other stuff and whatnot, there's going to be slightly different arguments and whatnot. And then fun is our function to be applied, right? So I think this works with like inbuilt functions with R. So if you could define your own function and whatnot, but we're just using the mean function. So let's do that. So let's calculate that here. And a nice thing about R is if you're trying to get the results immediately after you define the function, you can hit the this button, the colon and the comma. I think it's a semicolon. I should know this as a college student. But this kind of means like after, right? So we could do row.mean. So what we would do is we would hit this. My lord. So yeah, so that's like on the same line. So if we wanted to figure it out and see it immediately, we could do that. So that's a nice thing to do. So you don't got to add a new line or anything. So yeah, so as you can see, we've got the row mean for all 250 rows. And look at that. It's one line as opposed to before, right? We had to do all this annoying definition and then for loops and define the number of rows, blah, 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 blah. It's just really annoying, right? So apply is really nice, especially if you're working with vectors and stuff. So let's do the same thing as before with column mean. So let's call it call.mean, and let's give it apply, and we'll use the same big matrix to, and we'll apply the mean function, and let's do call.mean afterwards so we can see what we got. So yeah, so we got the same thing before, but look at that. That's way more cleaner, way more easy to use. You know, we don't got to define all a vector to store it all to. I think it's computationally faster as well. So yeah, so it's nice. It's kind of nice with it. So that's a really handy thing to use if you're trying to iterate over a bunch of stuff. So let's use lapply. So our previous example with the Grammys isn't completely useless here. So let's use the lapply function. So the number of characters underscore gram, we'll just call it that. And let's do lapply. So lapply is mainly used if you're going to function. It's a function you're going to use if you want to iterate over a vector or a list. So like a singular dimension, right? So if you can see here, right, the arguments are just x, which is our data set, and then the function. There's no rows or columns, right? So this is like a singular dimension thing, right? So if we want to iterate over a list. So our data is Grammys, and then our function that we want to use is nchar. And then let's nchar meaning number of characters, right? So let's do that, and then right, it gives us that. Hold on 1 second. I wonder if there's a 1 second. I'm just gonna change this from single quotations to double quotations here. Okay. Yeah, does the same thing. So yeah. Anyway, I was just testing because it says, you know, it gives us here, but as you can see before, it gives us each of the character lengths for each of the elements. So the first element, and it's returning a singular vector 6, 5, you know, and so on. So yeah, so that's how you would use lapply. So let's do sapply. So sapply basically a similar thing to lapply, except that it will put it into an array, and the S stands for simplify, right? So, and if it can't store it into an array, it'll basically just give you the same result as lapply. So let's kind of use the same Grammy data and kind of apply it here. So let's do sn gram, and let's call sapply function, and we're going to do the same thing. So Grammys and ncar. So Grammys is our data, our x, and then ncar is the function, right? So let's run that, and then let's find our results by just straight up calling it after. Right, so this one, look, this one returns us a much nicer one than before, right? Because just the simple lapply tells us the first one, the second one, whatever. But this looks a lot nicer because we already have those names defined for the Grammy. So, and by array, basically, it means it's going to match them to the data, so it's going to be easier to use. So yeah, so we can also use, you know, vapply as well is another useful one. But I find myself personally using sapply and lapply the most. So cool. So let's do vapply. So let's call this vn underscore gram. Let's use the vapply function. So do Grammys, ncar, and before. Vapply is very similar to sapply, except now we have to specify the specific output, right? So we're gonna do, it's gonna be numeric and length of 1. We only want a singular numeric vector, so that's what we're saying by that. And so let's look at that. Gives us the same thing. So these are two ways to do the same thing. I mean, it's really situational. I don't really know maybe if I don't know why I'd ever use vapply, maybe in like some weird thing where I have to change the type or something, but I would say in real world applications or in the classroom, you definitely would be using sapply and lapply the most. Cool. Any questions so far? Cool. I'm going to take a minute break here and just use the restroom, but I will be back. So I'll be back shortly. Alright, I am back, so let's continue on here. Cool. So we covered sapply, vapply, and that sort of stuff. So let's finish off this section before we cover Plier with while loops. So while loops are just a nice thing to have, right? So let's set I to be 0. So while I is less than 5, do this. So they're similar to for loops, but they kind of go until their condition is met. I don't know why I put on my headphones. Out of habit, I guess. So while I is less than 5, we're going to print I. We're going to give I a value of I plus 1. And then it's going to print I. Let's do that. Okay, it didn't do anything because I don't think we set I. Okay. Yeah. So it prints. So they're very similar to for loops, right? But they run until you define a condition and have a condition set. So the next thing that we're going to talk about is Plier. So Plier is really nice. So a lot of the functions in R, like base R, they're nice. They get the job done and stuff like that, but they don't really. There's faster ways to do them using packages and stuff like that. So the Plier is part of the. Plier is a part of the tidyverse, which is like a group of packages that includes like ggplot, Plier. I don't know. There's some other ones I can't remember off the top of my head. But Plier, if you're doing any sort of real world data application, most of the time the data that you get, it's not going to be already clean unless you get the data set from like Kaggle or something. But yeah, about 0% of the time it's going to be immediately useful. So the first thing that you have to do is kind of clean the data and get it to be usable. So if you don't have Plier, we're going to install it. So this is how you would install something. If I'm installing a package, usually I just type it in the console, because if I'm saving this for later, I don't need to install it a couple times. Or I don't need to install it again, right? So we'll go into the console, we'll type in install.packages, and then we're going to install Plier like so. and we'll just hit enter. And let's see. May take a second. Alright, so blah blah blah. It's gonna show you this. I guess I don't have it installed. Maybe I do. Okay, so it's gonna install here for a second. Shouldn't take too long. Okay. Okay, I might have an issue real quick, but we'll see if it works. Can I call the library? Alright, that's fine. Okay, so install, we're going to install the Plier, right? We did that, so let's install the other package that we're going to use, which is datasets. It's called datasets. Whoops. Okay, so I already have datasets installed, so I already have it installed, so you shouldn't have to install it. Anywho, so now we got them both installed, right? Let's do some work. Blah blah blah. All right, so let's look at our data set. Let's call the library. We're gonna call the Plier. So we're gonna load it, and then we're gonna call datasets. So how you load a package or a library is just you type library. Excuse me. Damn, allergies are acting up. You call the library, so library, and then just the name of the library. So now that we have those two libraries loaded, we're gonna use a data set called air quality. So let's check this data set out. So we're gonna do the head function. So the head function gives us like the first 6 rows of the data set and then all the columns. It's nice just to get an idea of the structure of the data set, right? So yeah, cool. No questions. All right, so what we're gonna do now is we're gonna filter. So what's really nice about the Plier and all of the Tidyverse packages and stuff like that is they have very readable commands. So filter does exactly what it sounds like, filters. So we're gonna filter air quality, and then our condition is gonna be where wind is greater than 5. So now we return all of the rows where air quality, where the wind is greater than 5, right? So you could do this probably in base R, but it would be a lot less readable and a lot more annoying. So we can add even more kind of specifications. So let's do filter, and then our data set, air quality. Oh, I can't spell tonight. So we'll do the temp is greater than 80, and so we can add multiple things here, and month is greater than 5, and then we enter that, and then it gives us it displays all of the results that match both of these values. So another nice thing about the Plier is that we can use a mutate function. So what we can do is we'll call mutate, and then our data set's going to be air quality. And so what's nice about mutate is you can add on columns to existing data sets, you know, and define how those data sets are defined, right? So we'll see here. So we'll do temp in C. We'll call it temp in C. Is our existing temp value, so temp minus 32 times 5/9. Yeah. So if we do that now, we can look at air quality, and we see we have, okay. Actually, I think for this you're just supposed to use equal. My bad. Yeah. So if you look, if we set the equal to, yeah, for this you want to use equal because we're defining, this is our new vector that we're adding to it. So you want to use equal and not the arrow thingy. right? So now we have temp in C, and it's converted all of our temperatures to Celsius, which is really cool. What's really nice about the Plier as well is we can use summarize. So let's use the summarize function. So we'll summarize air quality. And then let's summarize it by the mean of temperature. And we're going to add the argument na.rm equals true, which basically means we're not going to include empty values. So let's do that. So the average temperature of all the air qualities is 77.8. So cool. Will that permanently change the data set? Okay, so that's a good question. So, okay, with the mutate function. Let's see. So if I believe, okay, so we just did that. So so we ran that code. If we call air quality now, if we look, it didn't change it, right? This just adds it. If we wanted to actually apply it to the actual data set with the mutate function, set air quality equal to like that, and then that would change it to the air quality, right? Then that would apply that. So we would mutate and add that on. But just applying it doesn't store it, doesn't overwrite it, if that makes sense. So you would have to redefine it to kind of overwrite, if that makes sense. Let me know if that answers your question. So you would have to redefine it, air quality, as, yeah, unless you store it doesn't actually store the function, right? But we're going to cover something in a second called piping, which applies it to the data set itself. Yeah, no problem. So now that we've got that, right, let's check it out. So now we're going to talk about piping. So piping is really useful and a really good part of like more advanced data stuff. So we can do multiple things to the data without having to save each of the iterative steps, right? So let's use the same air quality example. So let's do air quality, and so to open the pipe, so to speak, you're going to use the number sign or the percent sign greater than percent. So this is the piping function. So we're saying air quality is going to get a pipe, and so we're going to do the same thing that we did before. So we're going to filter. Let's do month not equal to 5. So I did exclamation point equals, and my text changed it to not equal because I have a fancy font, right? So then we'll continue the pipe by saying, okay, it's going to pipe this next. And so we'll do mutate temp in C like we did before equals temp minus 32 times 5/9, same thing as before, and that's the end. So basically what we're doing is we're saying, okay, take the air quality data set and we're going to pipe it. So we're going to apply multiple things, but in this it's nicer because we don't have to assign it. So we don't have to say, okay, after this apply to air quality, after this apply that to the one before it, and that sort of stuff. So if you want to do multiple things, piping is really nice because, yeah, like I said, after we're doing it in sequential order, so that way you don't have to save each iterative like step. So if we wanted to do this without piping, we'd have to set air quality to that and then run it, and then set air quality to that and then run it, and do all that sort of stuff, if that makes sense. So it's kind of like we can do all of those things without having to do that, right? So yeah, so let's check that out real quick. So let's run that. So we can just hit enter, and so on the last function, we don't have to add any more symbols. So let's run this. right? And now we get the data set where all of that kind of stuff. And so to answer your question before, does this apply to the actual data set? No, it doesn't, because we didn't store it as anything. So anytime you do this, right, so we're applying it to the data set, but it's not overwriting the existing data set. To overwrite it or to create some sort of data set, we would need to assign it to a new variable or the existing variable. But this is nice if you just want to do, I mean, yeah, so if you want to just do some calculations without actually affecting the actual data set, you don't have to assign it to a variable and stuff. So the last thing we're going to do is explain group by. So group by is another good Plier function. So let's do air quality again, and then we'll do our little fancy piping function. So percent greater than percent, and let's do filter month is not equal to 5. There is a shortcut for the piping function, but I don't remember it offhand. And then we'll do group by, which is a function, and we're going to group it by month. So it's exactly what it sounds like, right? We're going to group it, and then we're going to use the summarize function, kind of tying it all together here. We're going to summarize the mean of temperature, and then exclude the random or the empty values. So if you run this, so we've got our months that are not equal to 5, so 6, 7, 8, 9, and then our average temperature. So we've done this, right? We took this very large data set and we filtered all the months, right? And then we grouped by the months. So we're kind of subsetting, we're grouping by month. So group by is really nice because we can kind of, so if it's a factor or, you know, an integer or something like that, right? We can just take each of the distinct values for that vector and then summarize it based on that. So we're taking our large data set with all the different months, and so we're going to first filter it by taking all the months that are not equal to 5, so ignoring the 5th month, right? And from that data set where we ignored the 5th month, we're going to group that data set by month. So we're going to take all of month 6, all of month 7, all of month 9, all of month 8, and so on, right? And then we're going to summarize that because now we have 4 individual data sets since we grouped by, right? We have 4 different things or whatever. And so we're going to summarize our data, which means like we're going to present it by taking the average of the temperature. So all of these different, you know, all of the different group bys, they have all of the other air quality numbers and whatnot. We don't care about that right now. We care about the temperature. So we're taking the mean of the temperature, and then na.rm equals to true. We're basically saying we're going to exclude all of the empty values. So that way our averages aren't messed up. Because if you include empty values, you just get some like annoying stuff that you don't want to have to deal with. So yeah, so that about does it for R1. I think we're doing R2 next week. So my name has been Will. I'm going to stick around for a couple more minutes. If you have any questions, feel free to ask me anything pertaining to R, or if you have any questions about the code and stuff. I'll stick around for a minute. But thank you guys so much for sticking through. Hope it wasn't too boring. I try to make it somewhat interesting because statistics and coding and all that kind of stuff can be pretty boring, but I don't know, boring to some, I guess, but if you have a certain mind for it and you like numbers and stuff, it can be exciting. So but yeah, so this is kind of a really rudimentary introduction to the Plier, really powerful tool for cleaning data and that sort of thing. And piping, you can get some really advanced stuff. You could like add on even more stuff if you have even more advanced data sets and stuff like that. So I'm going to stick around here for a couple minutes if you have any questions pertaining to the code or any R questions in general. So yeah, thanks so much for watching. Hope to see you at R2. Miranda asks, so for your final example, the group by function makes 4 groups. Yeah, so let's look at the air quality data set. Right here, let me pull it up on a bigger window. Hold on. Okay. So yeah, so this is the air quality data set, right? So we can see the months. So we can see there's 5. It's 5 through 9 on the months. So we're taking all the months that are not equal to 5. So we have 6, 7, 8, 9. And so those are 4 distinct values. They're integers, right? So there's going to be 4 groups because there's 4 integers. Whoops, different assignment. So it's going to group by the integers. In this case, you would want to use group by if it's like either a categorical data value or whatever, right? Or if it's some sort of distinct integer. I don't know how it would work if it's like a double or something with decimals, but grouping by the month, since there's 4 other months, it's going to separate it into 4 groups. So we can actually see, let's test it out, see what it does. So let's remove the summarize function and just end this, and then we'll see what this gives us here. So if we just filter by the month, right? So yeah, so it's taking, so let's look at this here. I'm gonna save this to just a test variable to show you here. Okay. And what's nice too about RStudio, if you have like a data set you want to view and it's kind of ugly to look at, you can just type in capital V view and then your variable, whatever, right? So let's look at this. So if we remove the summarize function to see what the group by function actually does, we can see that, look, it's separated them into 6. It organizes all the 6s and then all the 7s and then all the 8s and then all the 9s in that number. So they're all like one after the other in the data set. As opposed to before, I guess it was similar, but basically the group by function makes the 4 groups, but it's more useful because basically when you have the group by, you're saying, okay, I want these to be the 4 groups, or I want these to be the groups, and then you would usually do something after it, like either summarize it or kind of take the average of each group or whatever, do whatever. So in terms of actually changing the data set, it just kind of defines it as 4 different groups, right? And then you would usually do something after that. You wouldn't just group by in this case. I mean, I guess if the data was maybe, if we group by, something else like day, where it wasn't in order, it would probably put them in order, like one after the other. But in this case, the data was already in that order, so we don't see much of a change. But the group by function is mainly useful if you're like gonna do something afterwards where you want to apply things to like certain groups. So let me know if that answered your question. I don't know if that was convoluted, but that's kind of my understanding of how the group by function works that we use. Awesome. Glad to help. So yeah, I'm going to give it another minute or two. But if nobody has any further questions, I'm going to end the stream. And if you're joining in at any point, this is going to be available to watch afterwards. So if you missed anything or anything of that sort, you can watch it later. So stick around for another minute or so. But if anybody has any other questions, we'll end it here. Awesome. Thanks so much for tuning in. Appreciate it, Sam. All right. Thanks for tuning in, everybody. I'm gonna end the stream now.